Welcome to the second video, part 2 of a tutorial series showing you how you can develop a client-server application. These videos are designed to support the networking laboratory component of the second year of the computer science degree at the University of Hull. In the last video, in part 1, we looked at step 1 of the suggested work for our sample course assignment, where you took the sample code from the class slides and made it functional in Visual Studio. In step 2, we're going to look at developing a minimal server similarly based on the slides from the class. And it suggests that you start with some of the code that you did in step 1 and you add to it some more material from the slides. So that's what we're going to do. So if we go to what we had from step 1 and we can copy that. So instead of editing it, we need to make a new project. So we can copy that code and we can do File, New, Project. A new console application. We check the location, it's in the G drive where we want it to be, and we need to know what to call this. So we need to know the name for the server. So we could go back to the assessment description and it says the server is called Respond. So we can call the name of this solution Respond. So then we can go OK. So here we've got a new program for Respond, and we can paste in the text for the program that we had working earlier. And what that gives us here is a working main program. So the next thing we can do is then go to the PowerPoint slides that we had earlier, and now we need to add the slides for the server. So here's the server material which we can add in. So we copy that, and this doesn't have a main program. So we need to use the existing main program from our working program, and we would want to call the suggested piece of code from there. Now we've got this piece of code that was in the main program, and it also says in the notes, if we go back and look at the notes here, you'll need to demonstrate, we're going to look at step 2, it says you'll need to demonstrate a method called doRequest. So we could put this method called doRequest, which contains some of the code from step 1, which contains some of the networking that we might need to do. So we've got a few things to sort out here. So it doesn't like run server, and it's got something, it says object reference required for the non-static. That's because here actually this is public void when we want a static. So if we change that to static void, you'll see that error goes away. Here, this one, it says that name couldn't be found, But actually if you look very carefully, there's a spelling mistake that you need to fix. Listener. Now that error's gone away. So here's do request, and it doesn't exist in the current context because actually it has a socket stream in it. So we need to put in here an argument that represents the socket stream, and we need a type, and the type for socket stream we can see is type network stream. Okay. So we've got a few other things. Now obviously inside do request we don't want a client and we don't want to connect it to a server because we're programming a server, so we can delete those lines. Now we've got a problem that because we don't have a client, it doesn't know what stream to open. But that's okay, it's been passed in. So I can paste that into there. And there. So now it's saying, oh, we don't have any args. So well, actually we're not going to do anything with the args here at the moment, so we can delete those lines because the args was some of the thing from the main program. So we've deleted some of the unnecessary things that we didn't need from the main program. And we've got a few other things that are not working yet. I can just comment those out for now. Now it's complaining here about this TCP listener, and it's actually saying it's deprecated. Well, that's actually not anything we necessarily have to fix. The word deprecated means it's old-fashioned, it's obsolete, it's not supported, but it still works. And as it says in this text here, the method has been deprecated, use an IP address, and then it gives a link to some text at Microsoft that you can look at, and so we could go to that text at the Microsoft website and find out what's there. But what it would tell us is actually we need to put IP address.any on the site. Now it's saying it doesn't know what IP address is, and the reason for that is we need one more using. We need using system.net as well as system.net.sockets, and now that's happy, but actually the code is the same as it was before. So last error here is the name log doesn't exist, so we're imagining a class with a logging function here. So we don't have one, so at the moment we can change that to a console write line. Okay, so we seem to have got rid of all the errors now. So we've got some code here that we adopted from our part 1, our step 1, showing how to read and write from streams, and here we've got some code that came from our sample 1, and here we've got a main program we just adopted from the other one. So we could now build this solution, and we could start and try and run it, and we had that problem we talked about before where an error message flashes up and we couldn't see it, but we now know if we start without debugging we get to read the method, and it says here, not listening, you must call the start method. Okay, this is actually explained in the PowerPoint slides. If you look at the slide here, it says after you've called a listener, you need listener start, but in the sample code we didn't put that. So that's actually a deliberate omission from my code to check that. So now we need to add the listener start. Just after we've created a new listener, as it shows in the thing, and then we can build the solution. And now we can run this solution, and it doesn't do anything, it just sits there. So if we go back to ACW description, part 2, it says here that using the Windows built-in program Telnet to interface with it, and it has a footnote, and in the footnote it says Telnet is disabled normally in Windows, so you might have to enable it. So in our laboratory it's normally enabled. So what we can do is go to a command prompt, one that we had earlier, and we can try and telnet to our thing. Now our own computer is called localhost, and the listener is listening on port 43. So if I move the window, you can say we're listening on port 43 to any address, so we connect to it. Now let's see if this works. Right, because it says telnet is not a recognised command, it means we've now got to tell Windows that we want to add that. So we have to go to our control panel, this is in Windows 8, and then we can make some changes to the programs, and we can turn Windows features on or off. So if we scroll down, we should be able to find Telnet, and we need Telnet client, and we can just turn that one on with ticking the box, and we say OK. We apply the changes, and when that's done we should be able to go back to command prompt, and it should be able to find Telnet for us. So we can close that. We can close the control panel. If we go back to our command prompt, we can now telnet to port 43 is connected, and we can type something. I'll type some random characters, and whatever we type just keeps going. That's because here in the do request, what has happened is we created a listener, we've started the listener, we've waited for someone to connect, it's accepted the connection, and then once we've got the connection, we've asked it to read to the end. So we've got to send it the end of input, and we do that by doing control square bracket in Telnet, which gets us to there, and if we type quit, it closes the connection. But here we've actually got the random keystrokes that I typed. So we're beginning to get a little server that's sitting there and doing something. We've still got the server window, and if you're not sure, we can telnet through it again, and I can type something sensible. Then I have to do control square bracket to get into there, and then I press quit. It actually says hello server. So there's a couple of things to talk about here. Is why, when I type hello server, does it not echo the commands? Well, that was explained in the lecture course when we get to here, because there are features of Telnet that you can enable or disable. So if I say set local echo, it says local echo on. Now when I type I can see it. So normally local echo, in other words display on the screen, the keyboard is turned off as the default in Telnet. If you want to see keystrokes you can turn it on, but usually you can just type. So if I now quit again, it displays, the server has displayed. So you can see I can make a connection, I can disconnect, and I can connect again. So what's happening is this loop is going round, handling each connection, waiting for it to be finished, then going round and getting the next one. But how do we know that? Well, we can make some changes to our server code to actually print out what's actually happening. And it says in the coursework specification, if you look at it, that your server should do some logging. So what we're going to do, let's close the server or stop it. We haven't put in a command to stop it, so the only way we can actually stop it is we can just make that window go away, or we could press the stop button on the execution. So we might want to print out some things in our new server. So I could print out a message like server started listening. There. And every time we receive a connection, I could say something I could say connection received. And then I'm in the do request. So I could save that. I can build this solution. I can start running it again. And now you can see we actually says server started listening. So I could go back to my other window. I could connect to Telnet. Notice as soon as I got connected to Telnet, it says connection received. So we know it's done that. And then I can type my hello. I can do a control square bracket, and then I can type quit, and there it's printed out hello. So we can see we've got our basic server working, but it's not implementing everything that we need to do in the coursework specification. So we need to look in more detail at the specification for part 1 and see what we have to do. Now we've got the basic framework of a server working. Now we need to make this server conform with the specifications of the coursework. So we need to look back at the coursework description here for step 2 and see what we're supposed to be doing. So it said you should implement the basic commands of echo and no-op in your initial server. So those are the main things that we need to have to do. So we need to go back up to the looking at more of the specifications of the coursework. So we've done this, the main part here. We've got a program called server called Respond. We are using TCP sockets using SystemNet. And we've been using the command prompt interface to run, and so we've got various things of the interface. Now this is about the client, so we're not going to implement that because we're not implementing the client. So you need to find where are the things that the server does, and this will be in the protocol. So the server waits for the client, and it operates on port 43, and it has the commands no-op and echo, and that's what we've got to do here. So here's the basic command syntax. So our server has to read either no-op like that or echo like that. So we can see it's no-op and there's carriage return line feed, echo, a space and some string, and carriage return and line feed and these other things. we don't need to worry about now. So that's what it receives. Here it's got the responses. So for an echo it sends back this, and for a no-op it just sends back nothing, and we don't need to worry about the other ones. On the bottom here it tells us what the CRLF means. It means the carriage return and line feed, and that's actually what write line does. And it says here in the specification that it's done in ASCII, but this is the default action, so we don't have to do anything about that. So let's go back to our program. Let's stop the server running. Let's go to the code and let's do what's necessary to implement the course. So one of the things is to make it more specific to this particular assignment. So it's got nothing to do with who is, so we could now say this is all to do with something called respond. So now in this part, which at the moment it just reads whatever is sent and displayed, we now need to read the specific commands. So let's comment that out and actually do what we really want to do. So we saw in the protocol specification it was going to read a line that contained a command, so we probably do want to read a line, and so we could just use the read line on the stream reader, which gives us the line. That's all we need. We don't need to get the end, we just need the first line and find out what that line is, and that's our line. Now that line might have some carriage returns and line feeds on it, and we can just remove those with a trim. Now that trim, if you remember, is something that was actually done in the that you learnt in the yellow book, trimming here. So that was already taught last time and is in Rob Miles's yellow book, just as a reminder if you don't remember seeing it. So now we've got the line without the carriage return line feed on it. Now it says that could be one of two things. So that could either be the command echo or the command no-op. So we want to find out which one it is. So as we've got a choice of several things, normally one would do something like a switch. So we could do a switch on the line, and we could say something like, if it is the case, we don't need to put it in brackets, it's no-op, then we could specify what we wanted to do if the line was no-op. And actually the thing we usually want to do is actually says for no-op we have to do nothing. But although it says the server should do nothing, it's a good idea for it to log that on the screen, that that's what we've done, so that you can read so we could say I've performed a no-op. It might actually be useful to write out what you received. So here we could say read the line, we just say what line we've received, we do a switch on the line. If it's a no-op, we said we've been asked to do nothing, so we've done nothing. We could also put in here a default action, which we could actually say that would be recognized command. Now, you could think that maybe we should put echo in here and do something on echo, but we've got a problem now. In that if we look back to the protocol, the line has got more on it than the word echo. Let's go back to the protocol and we'll just see that now. Excuse me. So we can see here it has echo followed by space, where this one just is the no-op. So we've got to somehow chop this up at this space and get the string. So we need to find a way of doing that. So we really need to chop up this string into pieces. And we could call those pieces sections. So the sections of the string, and we need to split that up. And there actually is a function called split that we can use in C# that splits up strings. So we can split the string, and actually what we want to split it on could be, for example, a space. With that split, actually what we do want to do is make that an array of chars. Wrong, silly me. That's an array. And now that can split it on the character space. So we get the sections of the array, and now instead of splitting on line, we can split on the first section, and then if it's an echo, we can write out that the echo has been performed. Now the echo wants to send something back, so what we send back with SW write line, as we saw earlier, and we can actually send back the next section, not of the line, not forgetting to flash it back. Now there is going to be a problem here, because this string itself could contain spaces, and it does say it could contain spaces in the specification. So it does show here that it can contain spaces, so we want to say hello there, it can echo hello space there. the way we've written it, this code would only send back the one word hello and not the word there. So we don't need to chop it up into many pieces, we need to chop it in 2 pieces, and actually there is a version of split that does that. If we put comma 2, we only get 2 pieces, 0 and 1, and it doesn't split it anymore. And you can discover this by reading about the split function on some internet tutorials. So we perform the echo, and we can say returned. And we can say we return the section. So now we've printed out to the screen. If we've got a no-op, if we've done an echo, we perform the echo function. If it's a command we're not expecting, we can say that. So that's almost all we need to do. And we've got to try catch around it if anything goes wrong. And we've renamed it. That's so that we've implemented quite a lot of the initial functions of the thing. So we can now try and build this solution. It does appear to have worked, and we can now start our server running, and the server says it started listening. So then we could call up our command prompt, and I can telnet to it, and I could type no-op command, and we could see that it received a no-op, and it performed a no-op which sent nothing back, and closed the channel. That's exactly what the protocol says. I could perform an echo and then a space, and I can say hello there, and you can see the server has received the command echo hello there. It's performed the echo, it's returned hello there, so it's separated the command from the parameter, and what we have back here are the words hello there. We can go over here to the specification, and we can see that it has done what it's been asked. It sent the string and then dropped the connection, and if it was a no-op, it just dropped the connection. So we've implemented most of those functions of the basic server, which is one of the things it indicates in part 2. So then we're going to move on and add more functionality to the server, create a working client, and you can see how we're moving through step by step. But you can see the lines of code that we've got is not very big, it all fits on one screen. We can see all the code together, and you can see how the functionality maps onto the specification, how we've implemented that. So although it looked a lot with 7 pages of specification, you can see in terms of lines of code, it's not very many. You can see how the functions that we are using in C# are ones that were introduced to students in the previous year and are in the course text for last year's work. And that's why it's useful to have the books and the text at hand, because you will need to find these kind of functionalities to do the programming. You're not expected to remember them all in your head, but you are expected to have access to the books to work out what you need to do. So I hope you found that useful, and then there'll be another part to the tutorial series explaining how you can progress the work.